Hello everyone, welcome to the first video in the prerequisite review for Calculus 1 or Math 1554. First we'll be talking about horizontal and vertical asymptotes, and we need to know how these work for graphs and functions. We have two types of asymptotes. We have horizontal, and we also have vertical. Start with horizontal asymptotes, and we have three types of these. If we have a function a over b, we need to look at the highest exponent of this function. We'll take both of these to be polynomials. We'll say the first function is cx squared plus dx plus e, and the bottom function is fx plus g. Now, because the numerator polynomial has a greater exponent than the denominators, this just means that the horizontal asymptote will be non-existent. And this is because when the denominator has a smaller exponent than the numerator, we can essentially divide this out and it will become a rational function. Now, if we have our functions a over b, and we have something like fx plus g over hx plus I, we see that the exponents are equal to each other, 1 to 1. So what we do here is we take their coefficients, f over h, and this becomes our horizontal asymptote. And with f over h, we can also draw a graph to show how our horizontal asymptote works. F over h is our horizontal asymptote. It's how high or low our horizontal asymptote lies. We can call this f over h, and it is a distance f over h up from the x-axis. Lastly, if we have our two functions, and there's something like fx plus g over cx squared plus dx plus e, then our horizontal asymptote is just the x-axis, or y equals 0. Now for vertical asymptotes, we need to look at when this bottom function equals 0, which x value. So if we take a look at two of our functions, let's say we have cx squared plus dx plus e over fx plus g, just like the one above. We need to figure out what x value makes this function equal to 0. So we set fx plus g equal to 0, and to get x by itself, first we need to subtract g from both sides, and then finally divide by f, and negative g over f should be our vertical asymptote. And that's about it for asymptotes.